Hello and welcome to the web series ZeroPM Pieces. My name is Sarah Hale and I'm the project coordinator of a really exciting new research project called ZeroPM. In the ZeroPM Pieces, the researchers in the project will tell you about one piece of the ZeroPM puzzle that they're working on. So without further ado, here comes a ZeroPM piece.
So welcome everyone for this ZeroPM Pieces lunch seminar. I'm Raoul Wolf. I'm a senior advisor at the Norwegian Geotechnical Institute, and I'm going to present to you our work that we have been doing as part of Work Package 5 to build the ZeroPM database. When we look at the ZeroPM work package structure, some of you might be familiar with this. We see that all of the different work packages are intertwined and connected to each other, and this is something that we would like to showcase with this seminar series as well. Today we'll focus on work package 5, where I'll present how we built the ZeroPM database. When we talk about work package 5, which is about substance grouping, I thought it would be a great idea to remind everyone of the strategy that we had for work package 5. There's prioritizing PM substances and groups based on intrinsic properties, exposure and hazard, to select those substances to prevent and remove most urgently. And when we look at this strategy, we can see how work package 5 really connects to all the other work packages, as it focuses on prioritizing, but also works towards the prevention and removal aspects of the other work packages. In the tools and technologies that we are using in work package 5, we stated that we'll use algorithms to identify PM substances on the global chemical inventory for utilization by green chemical innovation and policy approaches. And a global chemical inventory, which is sort of the key word here, is something where when we think about it, we can see that yes, this is actually a database, and this is where the ZeroPM database of work package 5 will start. Now I want to spend a couple of minutes on first getting on the same level in terms of what a database is. A database, and I'm using the definition from Wikipedia here, which is very short and sweet, is an organized collection of data stored and accessed electronically. I put an emphasis on the organized collection of data because not every collection of data that we have is necessarily organized, as some of you might be familiar with. I certainly am. When we talk about databases, we also have to talk about what's called a database management system, DBMS for short, which is the interface which provides the functionality on how a database operates. Because remember, the database in itself technically is only a storage or access place. In practice, though, when we talk about a database, we usually mean a database in terms of data storage plus the management system it comes with, such as a PostgreSQL database. So whenever from now on I refer to a database, I will refer to both the database and its management system. Of crucial importance to any database, that's both the above terms, is a data model that defines the logical structure of the database. That sounds a little bit abstract, but what it essentially means is, for example, how many tables do we have in our database? How are different sets of data related to one another? Are there shared identifiers, etc.? So this is a really crucial point. I now like to talk a bit about core functionalities of a database. The first core functionality is the data definition, which is a part of the data model actually. And it's the creation, modification, and removal of definitions that define the organization of the data. That's a lot of definitions and defining here, but it is essentially having a plan and definitions for how the database structure, its skeleton, if you will, is set up. Like the crucial bread and butter functionality is the updating, insertion of data, modification of data, and the deletion of actual data. And this is really what many people think about when they think about databases and their functionality. Another very important and very logical functionality is the retrieval. It's providing information in a form directly usable for further processing applications. That means if you want to access a database, what will you get back? Most of you likely would like to have, say, a nicely formatted table back in a file, whether it's a CSV file, an Excel file, or whatever. That's certainly possible. If you want to use the information from a database for further programming processing, for example, you might need a different data format. So that's also one of the functionalities that a database has, providing the right format for the task. And last but certainly not least, the administration. That's registering and monitoring users, which is done, for example, to enforce data security. In reality, not every user will have access to every part of the database, etc. Administration also encompasses the recovery of information or the versioning of information, which goes a little bit back to the second point, the updating. For example, if we delete data, usually that data is not actually deleted, but it is flagged as being, for example, out of date. All of these core functionalities and databases in general have a other very important underlying principle, and it's certainly true for a lot of the work we do, not only in ZeroPM but in other projects as well, and that's garbage in, garbage out. Sometimes other words are used for this phrase, but the principle is the same. If your data and the quality of your data is not really secured, if you don't have a data curation quality assurance process before you store data in a database, anything this data will be used for subsequently will also be of inferior quality. So that's an important principle to remember. Now, when we go back to talk about the Work Package 5 database, the big ZeroPM database, and the global chemical inventory, we of course have to mention the great publication from my colleague Zhen Yung about the first global chemical inventory from 2020, and we will actually take this publication and the database thereof as a starting point for all our work we do in Work Package 5. So let's talk a bit about the Work Package 5 database. We aim at having a fully reproducible reconstruction and update of the global chemical inventory. And I have that fully reproducible with a little asterisk, because it might be that we have to anonymize certain data sets. We will update, but not only update, also extend the publication from Zhen Yung. We will identify and verify all source data from the inventories. And it is our goal to FAIRify the data model. And I'm sure not everyone is fully familiar with the term FAIR in this context, so I'll take a step back and explain that briefly. So when we talk about FAIR, it's, as you might have guessed, an acronym, and now we'll talk through the 4 letters here. The F in FAIR stands for findable, which means that the data and the metadata are machine readable. In simpler terms, if you type ZeroPM data, just as an example, into Google, you get a result that leads you towards the ZeroPM datasets, for example. But we also have a GitHub repository where we share all our code, publicly available, open access, and we have a Zenodo community for our data sets and other deliverables. You see the links on the screen. They are already actively used, so I urge you to check them out. The A in FAIR stands for accessible. And that means that in the case of the ZeroPM database, no special authentication will be needed. But as I stated earlier, parts of the database must be anonymized for the public. In terms of accessibility, there is one but that I need to mention, and that's that we will safeguard against too many queries per second attacks. The I in FAIR stands for interoperable, and for the ZeroPM database, that means that the data will be stored as so-called blobs, that is just the raw data as is, but also in clean flat tables, and everything will be retrievable in openly available formats such as CSV or TSV. The R in FAIR is for reusability, and that is especially important for the description of the data and metadata. We also have already developed quite a number of R packages that go with all the functionalities of the ZeroPM database, and we want to use permissive licenses for everything we do, whether it's functionality in terms of R packages or just data sets, by using permissive licenses such as MIT. Now, when we think a bit further about what actually needs to be done work-wise when we work on the database, it's a reasonable formatting and cleaning of the data sources. If you have worked with chemical registries or inventories before, you might have noticed that not every file you get or every official document you get is nicely formatted in a way that it can immediately be read into, for example, R or Python, and then be passed into a database. So there's a substantial workflow for identifying raw data, cleaning and formatting this raw data. We are also in the process of developing tools and workflows to uniquely identify the structures of single substances here. And I'll jump directly to the next point. We will use the INCHI identifier as our universal and unique structure identifier for substances, as opposed to, for example, SMILES or CAS numbers. And as I stated earlier, we will provide, and we are already providing, extensive documentation for all our workflows we have developed thus far. Now a few words on the current status, and I have timestamped this on the slides here because now we are speaking in early mid-May, and surely this will be outdated soon, but I thought it would be nice to include it no matter what. When it comes to chemical inventories that we have already cleaned up and formatted and fed into the database, you can see that we have 7 inventories included already of varying sizes, but also just a sheer number of data points here, which is really rows in tables, tells you that there is a lot of work to do and a lot of safeguarding and quality assurance to do to make sure we actually have a well-behaving data set for each of these inventories. For this task, this cleaning of the inventories, we have developed two R packages. R, for those of you that don't know, is an open source statistical programming language. And the two packages are called CleanVentory, which I thought was a nice pun on cleaning inventory. You can download and install that package from ZeroPM's GitHub. It contains all the functionality to clean the raw data of the 7 inventories that I just mentioned and turn it into very nicely formatted tables. If you're just interested in the final cleaned data, we also have that as an R package. It's called CleanVentory Data, also available from the ZeroPM GitHub repository. We have also developed 2 or rather 3 R packages that we are now currently in the process of using to setting up a workflow of identifying the unique structures for substances. All of these packages use so-called API functionality. That means that it's a programmatic access to functionalities from a server. For example, in this case, for the CAS Common Chemistry service, so we can, in a very dynamic way, search for example, chemical names and get an identifier back. Like I said, we have a package developed for this as well. It's called CCC API, and it's available from the ZeroPM GitHub, of course. But we also have developed and are still actively developing functionalities for a PubChem API package called PC API, where we are also working together with some of the PubChem developers. And again, that's available from ZeroPM's GitHub. In a bit of a shameless self-plug, I had previously, way before ZeroPM, developed a R package to connect to the ChemSpider API, which we are also using, and that's part of my personal GitHub repository. Now the next steps in the very foreseeable future, this will be, for example, a identifier structure mapping score, because not for every name, for example, or for every CAS number you search for on whether it's PubChem, ChemSpider, or the CAS Common Chemistry services, you will not always get exactly one structure or even the same structure back. So there we are currently in active development to develop a scoring system. We will integrate our PostgreSQL database into a so-called Docker container, which is essentially a virtual computer, if you will, so fully digital, that you can start and stop at will. And this will also greatly help migrating all of the ZeroPM database, once it's in a Docker container, into the cloud to make it more accessible. We will provide additional functionalities in the Docker containers, for example, through OpenBabel and CDK. And of course, last but not least, we will also develop and integrate PM prediction models. With that, I'd like to stop and thank you all for watching this presentation, and I look forward to seeing you all somehow, some way. Thank you.
ZeroPM. Zero pollution of persistent and mobile substances. This project has received funding from the European Union's Horizon 2020 Research and Innovation Programme under Grant Agreement number 101036756.